So here we're looking at the angles inside of an isosceles triangle. And there's a couple things we want to remember here. First of all, an isosceles triangle is a triangle where two of the sides are congruent. So two of the sides are the same, all right? That's important. We need to remember what an isosceles triangle is. And then secondly, we need to remember the relationship that exists between angles in a triangle and the opposite sides, okay? And so when we think about that relationship, all right, so I know that an isosceles triangle has two sides of the same, and I have this relationship that says, hey, the size of the angle and the opposite side are kind of related. In other words, the smallest side is across from the smallest angle. The biggest side is across from the biggest angle. But we haven't run into a situation where, what if two of the sides are the same? What would it tell us about the opposite angles? And so if we kind of extend and expand upon that relationship that we've talked about, if the larger the angle is, the bigger the opposite side, or the bigger the opposite side, the larger the angle, or the smaller the angle, the smaller the opposite side, well, what would happen then in terms of comparing the angles if the opposite sides from those angles were the same? It would stand to reason that those angles would also be the same. And so that's the idea we're getting at here. Just using that same relationship of, hey, the bigger the angle is, the bigger the opposite side, or the bigger the opposite side, the bigger the angle is. Well, if I have two sides of the same, then the angles are going to be the same, all right? If I have two angles of the same, then the sides are going to be the same, all right? So it's that same idea in terms of the relationship between the angle and the opposite side. And we just know as the angle gets bigger, the side gets bigger. But if the angles are the same, well, the opposite sides must be the same, okay? And so looking at this guy, here I have an isosceles triangle. In this isosceles triangle, based on like the size of the angles, we can see that angle B would be the smallest angle here because it's across from the smallest side. But then angles A and C are across from sides that are the same, which means angles A and C are indeed the same. So the measure of angle A would actually be the same as the measure of angle C, okay? Neither of those angles is bigger than the other because the opposite side, neither opposite side is bigger than the other, okay? And we know that if the side was bigger, the angle would be bigger, all right? But if they're the same, then the angles are the same, all right? So taking a look at something like this guy, if that relationship exists and if the sides are the same, it makes the angles the same, I can easily find all the angles inside the triangle. And so when I look at this guy, again, angle B right here is across from this side that's 12 units long. Well, angle A is also across from a side that's 12 units long, so it must have the same measurement. So angle A is also 75 degrees. And now from here, I can find angle C because the three angles inside of a triangle add up to 180 degrees. And so when I look at this, these guys give me 150. So let's see, 180 minus the 150 gives me 30 degrees. Okay? So now I have the measure of angle C as well. So again, we're still just using some of these things that we've already established, that relationship between the sides and the angles, and then using that idea of, hey, the angles inside the triangle add up to 180. Looking at this one, same kind of thing. Once again, I have two sides that are the same. And so if I was comparing the angles here, all right, if the opposite sides are the same, well, then the angles must be the same. So when we look at angle C, it's across from a line that's a segment that's 6 yards, and it's 46 degrees. Well, angle B is also across from a segment that's 6 yards, so it's also 46 degrees, okay? And so if the opposite sides are the same, the angles are the same. And now from here, let's see, that was angle B. Now I can find angle A. Remember, the three angles inside a triangle add up to 180. These guys together give me a 92 degrees. So I subtract and I get 88. Okay,